I hope you took a few minutes to work on finding solutions to these equations. Let's take a look at what the answer should be. For the equations involving sine, we can use inverse sine to find answers. If I apply inverse sine to the sine function, it returns simply theta on the left-hand side. On the right-hand side, of course, I get inverse sine of 1/5. 1/5, it's good to note, is a valid sine ratio. It's between -1 and +1, so I can make sense of it, and the calculator will not complain if I enter in inverse sine of 1/5. In degree mode, I get a value, an angle measure in degrees. So theta, one solution, is 11.5-ish, 11.53 degrees. So that, making a quick sketch on the unit circle, that's the angle that has a height in quadrant 1 of 1/5, a y-coordinate of 1/5. There's a second solution in quadrant 2, and we can find that by taking 180 degrees minus 11.5 degrees. And so a second solution would be 168.5 degrees. The process for -4/7 is the same, so if you had trouble with this first answer, I encourage you to take a moment, pause the video, and work on that second question. If I take sine inverse of -4/7, the calculator gives me -34.84. This is almost the same, except if I'm looking for solutions between 0 and 360, I want to turn that into an angle between 0 and 360. So if I add 360 to that, it gives me one of the solutions, 325.2 degrees. The second solution comes from taking that value, subtracting it from 180. So I can bring that answer into the equation and get another value. This is another possible solution. Again, it's negative, which is a little problematic. But if I add 360 to that, it'll give me a coterminal angle that is in the range that I'm looking for. So the second solution is 214.8. And it is always nice to have a way to check our work. And so if I take sine of 214.8, enter that in the calculator, I get -0.57, which seems a little awkward, but that's the same as -4 divided by 7, or it's at least close to. There's a little bit of a rounding issue, but it's close to -5.7. For cotangent, we need to first kind of translate this equation, or we can think of this equation as in terms of tangent. So cotangent of theta equaling -2.4, that is the ratio. -2.4 is the ratio. So tangent would give us a reciprocal ratio at that same angle. And so we can use inverse tangent of -1 divided by 2.4 to find the angle that we're looking for. So again, there's a solution of -22.6 degrees. That's outside of our range. We're looking for angles between 0 and 360. So I could add 360 to that. So a solution that is in our range is 337.4 degrees. The second solution on the unit circle, so this is in quadrant 4. The other solution is going to be in quadrant 2, and I can get there by adding 180, but of course that makes the angle too big, so I can find a coterminal angle by subtracting 360. So I guess really I could have just subtracted 180, but this gets us to the same answer, so I get 157.4 as a second solution. And we could check these in a way similar to what we just did with sine. Because we're dealing with cotangent, I could take 1 divided by tangent of 157.4, for example. And we can see that that's, apart from some rounding error, we see that that's roughly -2.4. So I can feel kind of good about those solutions by checking. In a similar way, if I want to find solutions to cotangent of theta equals 10, we can look at tangent of theta equals 1/10. And so inverse tangent of 1 divided by 10 gives me a positive solution. So one answer is 5.7 degrees. And then simply the second answer I can get from by adding 180 to that. That gives me an answer in quadrant 3. The first answer was in quadrant 1. And I get 185.7. Let me mention one last thing. All of these trigonometric equations have an infinite number of solutions. We just found the solutions between 0 and 360. Looking at this last example, we could find others by taking those two solutions that we found and adding 360 degrees as many times as we'd like. So if I add or subtract 360 degrees, I would find alternative solutions, other solutions. And so the set of all solutions would be 5.7 plus 360 degrees times k, or 185.7 plus 360 degrees times k. So often questions that we're going to deal with, they only want us to find solutions on one trip around the unit circle between 0 and 360 or 0 and 2 pi. But we could extend to an infinite number to the complete set of solutions by writing those solutions in this way. I hope you enjoyed the video. Thanks for watching.